Right, welcome back. More Chapter 3 information. We've previously been taking a look at univariate or single variable data and how do we process that. We've done a couple of things so far. We've taken a look at the mean, the median, and the mode of the data and how to use frequency tables to better just time saver when we're putting things into the graphic display calculator, and how do we access that information once it's all typed in. How do we find different key things. Now today we're going to be taking a look a bit at the ways that we present data. How do we visually present it in order for it to be better understood? This is not processing data like finding the mean, the median, or mode, but rather ways that we can visually present it so that it's better understood by us and also by whomever we're presenting the work to. Okay, the first thing we're going to be taking a look at is frequency histograms. Now, a histogram is a really fancy word for bar graph, but it has some very specific mathematical connotations. One thing it does is there's no gaps between the bars, so we're talking about quantitative continuous data here. Often we're measuring something. Let's take a look at this one here. It says a histogram, no spaces. Histograms are used to measure quantitative data. That's right. And the vertical axis is always the frequency of whatever's being measured in the x direction. So in the x direction, you're going to have a variety of things that could happen. And the height of the bar indicates how often that occurred. You're going to have to always figure out the boundaries of the classifications that go along the bottom, and there's a little trick to that. I'll show you what that's all going to be about here. Now, for example, I've illustrated these three ideas in green to show you what they're talking about. You'll notice that classification in the histogram there in the upper right, it starts at 3 and it finishes at 500. Oh, I see, I made a mistake here. I said 300 to 400 days is 300 to 500. And you need to work out what the upper and lower classifications are from a chart sometimes. Most often, however, the authors will tell you what they've got in mind. You just got to follow along. Okay, here's somebody named Belinda. She's collected data on the time in seconds that different girls and boys in her year group took to run a 100-meter race. And there's a lot of data for the girls and a lot of data for the boys. Now, to save you a little bit of time, I just went ahead and typed it in. But how you would do this in a testing scenario or in a project or whatever, you would come up with those classifications down the left side there. So we're going to take 1 second width classifications. Oh, and they always have to be the same width. So if you have the first one starting going from 11 to 12, that's a width of 1 second, then they all must be a width of 1 second. Otherwise, we'll be in a tricky position of miscommunicating data and not really revealing the underlying truth behind it. So it has to be the same all the way through. Then what I'm going to do is I'm going to go to my chart, and I'm simply going to make a little running tabulation there of how many of all the different ones occurred. So right now I'm not in any position to comment, to do anything with the data other than just tabulate it to get it into a table. Now, spinning ahead, and I've just gone ahead and done this. You don't have to. I'll show you how to do this soon. All of the different times there from that frequency table are shown. The frequencies are shown as by the height of the bar, and what we're actually measuring, the times for the boys and girls to run this race, are presented in the horizontal axis. Now, I actually just typed this into my graphic display calculator, and I'm going to show you what I came up with. We previously looked at the minimum time, the first quartile, the median time, third quartile, and maximum time. And I went and retrieved this information because I wanted to show you how just looking at the numbers themselves, it doesn't really give us a deeper, richer understanding until we really sort of pick at it a little bit. And here's how we're going to do it. We referred to this as the 5-number summary in a previous lesson. And I'm going to make a note of each of those for both the boys and the girls. So there's a summary of the fastest time. Now, in the case, like the lowest number of seconds, obviously, is the fastest runner. So that would be the minimum amount of time to complete the race. Lower quartile, median, upper quartile, and slowest. Remember, those guys divide up the data set into 25% chunks or into quarters. Now, here's our first view of what we call a box and whisker diagram. Some people just call it a box plot. And there's quite a bit of information that's conveyed in here. Now you'll notice there's a a little legend here that the girls are represented in this diagram using orange and the boys are represented using blue. And this diagram here is meant to convey the 5 numbers of the 5-number summary, one each for the boys and girls. Now let's take a look at the boys ones in the top here. The fastest time that was run was 11.5 seconds. Now it wasn't necessarily 11.5. I just know that there was one that was tallied up between 11 and 12 seconds. And so that is indicated here. Now that's the lowest that this line gets right there, and it's above 11.5. In the case of the median, notes 14.4, and that's right here. That's the line that separates this box. And then the highest one is 20.5, and that's way over here. More on why that one's a dot and not connected by a straight line. Let's take the other in a moment. 13.35 and 15.75, that's the levels that are here and here. So there's actually 5 numbers that are being summarized here in this diagram. One is here, that's the minimum, lower quartile or Q1, the median, Q3 or the upper quartile, and the maximum. These numbers over here are going to be set as outliers, and we're going to have a chance soon to discuss why that's true. Now, the same thing exists for the girls exactly. The median's in the middle, lower quartile, minimum time taken, upper quartile. So every one of these phases of the diagram, there's 1, 2, 3, 4 phases of it, represents 25% of the data set, or 25% of the girls who ran the race. Okay, let's go back and take a look at this again. There's the summary of the chart, and there's the frequency table, and there's all the different kids' scores, all 1 second. And you probably already saw that when we're going to process this on our calculator, we choose the middle number between 11 and 12, or between 12 and 13, to be the representative number for the group. So we're going to be calculating things like averages, means, medians, whatever. We don't have any more precision than to know that the boys at 2 finish between 11 and 12. So we just approximate to say we'll call them both 11.5, even though we don't have any specific evidence to support that. That's the best that we have. Now, there's a file called Grade 11, Chapter 3, Section F, Part 1. And I'd like you to open that on your desktop app with a GDC, so that way you don't have to type in all of that massive data field that you see behind here. I've already done it for you, and I've made a TNS file out of it. So if you click on that, you will be able to open it on your laptop and be able to process what's coming up. Hit pause now, and let's get that file. Now, when you get that, they're going to ask you to draw your own frequency histogram for it, and that information is going to look like this. Now I'm going to show you how you get that from the data that came in the initial tabs, and here's how you do it. So I've got all the different data there, and I've got the frequencies, and I've called the frequencies girls and boys, so the same times were used for both, the same time list, but I've created a separate frequency column for each of them. Now I'm going to go to statistics and make a stat calculation here, single variable. It's going to be the times, and the frequency is the boys. I have to do this twice, once for the boys and once for the girls. And you can see here there's lots of information to be gathered here. There's the 5-number summary at the bottom. 14.75 is the average. 40 students ran it. There's your 5-number summary there toward the bottom. Now I'm going to repeat that for the girls. Statistics, stat calculation, single variable, one variable. And in this case, the list is the same times, except I've changed the frequency for the girls and called it in the girls column. And I hit OK. And then I've got all that information again, but this time for the girls' data. Slightly higher mean, same number, 40 students, and the 5-number summary there at the bottom. Now, how do I present this? I'm going to make a new page. And this is going to be statistics page. You see the data floating around here? You just click down here at the bottom and say, this is where I want the time to go. And now I'm going to add a summary because it's a frequency table. So I'm going to go to property, going to add a Y summary here, number 9. And it takes the boys there first. Now I can add another one to it. What I do is I just go over here and I say, I can click in there and say, no, I can't do that. I can go to plot properties, I'm going to add another summary. So that's number 9 again, add a further one. So do 2 at the same time. And then you can see I've got 2 histograms going there based on that data. If I want to change it to a different kind of graph, I go to plot type and change it to a box plot. And there's the box plots that I showed to you earlier on, and that's how you make them. So it's the thing that we're measuring at the bottom, time. Notice as I hover over those dots there, it tells us the values of the 5-number summary as you go through. Okay, now to draw a box and whisker plot, you need to have 5 pieces of information called the 5-number summary. We've seen it a couple of times now. Smallest value, lower quartile, also called Q1, median, upper quartile, also called Q3, and that is a sample of what I found on the previous screen from the boys. I could have done it for the girls. And then here's the next part. An outlier, and I hinted at this recently, it's not just our perception of, gee, that number looks too big, or maybe that one's too small. It has to be more definitive and measurable than that. And here's the formula for it, and we'll practice it coming up. LQ is 1.5 times IQR. IQR is the interquartile range. We take 1.5 times it and take that number away from the lower quartile Q1 and add it to the upper quartile Q3. Those 2 new numbers that we're going to find become the range of values where we accept data. If it's outside that range, we say it is an outlier. Now, that's a lot to digest. Let's just take a look at what I've done here. So I've taken a look at those 2 values there. The lower quartile for the boys in blue, 13.5. Upper quartile, 15.5. The difference between those 2 is 2. I take 1.5 times that value and I get 3, because 2 times 1.5 is 3. When I do that, I then take the lower quartile number 13.5 and subtract 3, and then right alongside I take the upper quartile value 15.5 and add 3. That creates 2 new values for us, 10.5 and 18.5. What do I do with that information? I go back to the table and I see, are there any data points for the boys that don't reside between 10.5 and 18.5? And actually I see that there is. So this is the 18.5 entry here between 18 and 19. And there actually is one down here. And that's why that data point has been deemed outlier, and it's not attached to the box plot over here. It's indicated with a dot, and it's not continuous or attached to the rest of the diagram. You hit pause, or maybe you want to go back and try that again. I'm going to go ahead and show you the same set of steps that we're going to perform with the girls' data. So once again, I take a look at the girls' data, and I see there's the Q1 is 15.5, Q3 is 17.5. Now those are the boundaries of the box part of the box and whisker diagram. We're going to take that width, which is from 15.5 to 17.5, which is 2, times it by 1.5 to make 3. Then I find out what's 3 less than the lowest lower one and what's 3 more than the higher one. 3 less than 15.5 is 12.5. 3 more than 17.5 is 20.5. Now I need to check, does any of the girls' data reside outside of the 12.5 to 20.5 zone? So I'll bring back my table here and I'm going to look at the girls' data and say, oh well, yes, actually it does. I can see down here that this one is called 21.5. That's outside. And this was 22.5. That's outside. So if I go back now to my box and whisker diagram, you can see that those last 2 data points. Now what's subtle about this that you may have overlooked, the calculator did it automatically for you, but now you know why it's there, why these are calculated as, or presented as dots, and what that actually means. They lie outside the zone. They're not considered part of the main data set. They're considered to be statistically outliers. And so there you go. The 2 of them are right side by side, and the dots indicate that they're outliers. The rest of this stuff, minimum, Q1, median, Q3, maximum is still over here. We don't chuck the data out because it's an outlier. We will wait for the authors to say, should we keep it or not? Okay, one more quick example. I know this is getting kind of long here. Shoe sizes of boys and girls measured in European sizes, ranging from 34 to 49. 49, that's an awfully big foot. Okay, let's draw a box and whisker for the females and the males. Compare the 2 plots. There's a little reminder about how the formula works for finding the zone where the outliers are or are not. So once again, we're going to go now open the other one, grade 11, chapter 3, part F, part 2, and this is where this data is already entered, so you don't have to enter it yourself. I'll hit pause while you go ahead and get that file open on your GDC. Okay, we're back now. So you should have this data here, and it says shoe size. I can just log the shoe sizes from 34 to 49 and have the girls' frequency and the boys' frequency. The colors were separated. You can make them whatever you like. And you can see already that that boys 49 is going to be deemed an outlier, but we're going to check that out for ourselves too. You can also see that the smallest one for the boys is 37, which is exactly the same as there. Highest one for the boys, apart from the 49, is 42. That's right there. And the same, and the lower quartile is 38, higher quartile is 40, etc. So if I did the full summary here of all the boys' data and all the girls' data, and this is in the menu, statistics, one variable, and it's going to have a frequency of girls' frequency and then another one of boys' frequency. And I put the two side by side for contrast. Now, at this stage of the game, we're interested in the Q1 and Q3s for both. I've highlighted them, and I made a little calculation that the interquartile range for the boys was 2, like last time. 1.5 times that is 3. For the girls, coincidentally, it's also 2, so 1.5 times that is also 3. And then right here, I just made a little notation. 38 minus the 3 and 40 plus the 3 create a new zone, which is from 35 to 43. For the boys, that's anything inside that's considered non-outliers, and you can see 34, there's none there, and only the 49 is outside the zone of 35 to 43, so that's an outlier. And for the girls, anything between 34 and 42 is fine, and the girls do go from 34 up to 40, so there's no outliers at all. Do a quick little summary. I flagged that one is the outlier. The boys, the smallest one of 37 is not an outlier, but 49 is. And the girls, there are no outliers there at all. Okay, that was a long video. Thanks for your patience. We're in section 3F. Lots and lots of questions there, lots to do, and lots of them are assigned 2, 4, 5, 6, 8, 9. Let's get working on that. I'm here to help. Right, we're already getting quite close to the end of chapter 3.